Okay, so I want you all to pull up your Arduino IDE editor. You can do this of one of two ways. You can choose to download it from the Arduino website. If we go here, we can just go to software and downloads, in which you can download it, and or we can run it through the Arduino website, which you would click here. You would go to web editor, and it would pull up this here, in which you can code your Arduino directly online, which is really nice if you don't feel like, cluttering your desktop or whatever. But I am going to start off explaining the IDE or this interface with the downloaded version, just because that's what I started using, so it makes it's a little bit easier for me, but it's almost the same thing. There's only one difference. So if you feel like using the web editor, just skip ahead to that section. All right, so for this IDE, what you see in our first sketch is two sections that come up, which is the void setup and the void loop. So when we open up a sketch and we begin to code, there's actually going to be three sections. The section that is above the void setup, which is where we would name where things are connected. Let's say we have an LED on pin number 2. This section above void setup is where we would identify, hey, Arduino, we have an LED connected to pin 2. Just FYI, this is important. We got to label our stuff. Labeling feels good. So that's where you would label where things are, and where you would set up things that will never change, that just won't change when you code. So the constants. Okay, so the next section here is void setup, and this, like it says here, this is where you put your code that will only run once. This is sort of to set up everything, or set up the environment that you need to create the code that will loop, which is in this next section. For example, in this sketch, we're gonna just turn on our LED onboard number, the LED number 13, which is our onboard LED. And in the void setup, what we need to tell the code to do is we gotta tell it to make that LED an output. That is one time that we need to say it. Hey, we're just gonna send signals to this LED to just turn on. This is where you would put that information. And then in void loop is the section in which you would tell it to turn it on, and then wait a few seconds and turn it off. And then that will loop forever and ever and ever and ever and ever and ever unless you code it to stop or you press the reset button and it'll stop. Okay, so next I'm going to have you pull up examples, basics, and we're just going to pull up blank. Turns on our LED for 1 second, then turns it off for 1 second. We have nothing to really tell the board. There's nothing connected to any pins, so there's nothing above the void setup. But in the void setup, we have our pin mode, the LED built in. We want it to be an output. We want to send information to that LED. And in void loop, the function that will run forever and ever and ever is we will digitally write, because an LED is a digital pin, LEDs are digital, that we want it to turn on high, and which is a full 5 volts or the highest it can go. And then we're going to wait 1,000. It's wait for 1 second, which is 1,000 milliseconds. And then we're going to turn it off. Delay for 1,000. Great. So now let's plug it in and see what happens. Okay, this is when things can get wrong, right? So what we should have done before we even verified is we have to make sure that we know that our board is connected to the right port, that it is what it is, like it identifies itself as what it is. So we're going to go to Tools, and we're just going to make sure everything is working okay. So our board, Arduino Uno Wi-Fi Rev, that's actually not the board. It's just an Uno R3. So we're going to go here and click Arduino Uno R3. Oh, great. So that's the tool, but now we got to make sure it's the correct port it's connected to the correct port. So we know it's the right board, but is it connected to the right port? Oops. Oh, okay. So it's definitely not my Bluetooth or my mini jam box, my phone, but it's this one. Great. Click on that. Awesome. Now we know for sure that it is going to upload. It's going to upload to the correct port. Click upload, compiling sketch, done uploading. Awesome. Now let's look at that LED and see what happened. So now you see it blinking. 1 second, 1 second, 1 second on, 1 second on. Awesome. We did it. Great. So now we're going to switch over to the Wi-Fi, the Arduino web interface, and we're going to notice that this looks exactly the same. This looks a little bit different, but it's not, it's not difficult to follow. We see here that this is where examples can live. And so we're going to go here and we're going to go to basics and we're going to go to blink. Great. This is pretty much, it looks exactly the same as the one that we used. But the only thing is we don't have, a section up top that gives us tools or serial monitor or anything like that. But it gives us information right here. When you go into the section where you're looking for your Arduino board, you're going to select other board and port. But in order to do that, you're going to have to download a plugin that will help you locate your board if you're connecting it via USB. So just keep that in mind, that you'll be downloading a plugin so that you can figure out what port your board is connected to. Once you do, it'll appear just like this. Really, it'll just appear here. And then you'll be able to run the code just like we had with the downloaded IDE. We got our LED onboard light to blink. Yay! So now our next step is to wire up an LED. So what we got here is all the things that we need to wire it up. We've got our breadboard, our Arduino board, some jumper cables, an LED, and a resistor. So LEDs need resistors, without of which it would just burn out really, really fast. So what is a resistor? A resistor controls the flow of electricity to and from the thing that it's resisting. So in this case, the LED. It's controlling the flow of electricity to the LED. So the LED has a power side and a ground side. So the long side is the anode side, or the power side, as you can see. And then the short side is the cathode side, which is the ground side. So we just have to keep that in mind when we wire it up. So let's go ahead, and you notice this is the long side. This is the long side, so that's the anode side, power side, and the short side here is the cathode side. It's the ground side. So let's plug it in. We're going to plug the long power side into, let's start here at 5, and 6 is the ground. So we're going to connect 6 directly to the ground of our Arduino. Let's just connect it here right now. Great. We get LED connected to ground. Now we're going to connect the power side, but we're not going to connect it directly to the Arduino board. We're going to use a resistor to connect them. Great. Here, and we're just going to bend it a bit to get to the place where we're just a bit away from the LED itself. And then connect this end here to our pin. We're going to connect it to pin 3. So here we go. So as you can see, let's move this over so maybe you can see it a little bit better. It's a little bit easier maybe. Okay, so our short side was connected to this, which connects to the ground. Our long side is connected to one end of our resistor, and the other end connects to this side that connects to our pin 3. Great. So as you notice, this resistor has colors on it, and that's how we can tell how much this will resist. This one is, this is actually a 1K ohm resistor. And the way that you can tell is through the colors on the resistor itself. It essentially will tell you how much it is going to resist. And I'll put a link where you can sort of get a sense of, you can just sort of plug in the colors to know what the resistor, how much it is going to be resisting. LEDs are unique in that you can use resistors from 100 to 10K ohm. And the more that you use, let's say you're using 10K ohm resistor, the LED will be less bright. If you use 100 ohm resistor, it'll be super, super bright. So you've got a range. And you notice I plugged it into pin number 3 with a tilde, which means that I can actually control this LED in 2 different ways. I can control it just like a digital pin, on or off, or I could code it to have a range of output so that it can dim from light to dark or dark to light. Okay, we're going to go ahead and go over here and we're going to code it and we'll see what it looks like. Okay, so let's open up our Arduino IDE and we're going to also open up the example Blink, which we used in the last tutorial, in the last introduction. We're also going to open up Blink from the examples. You can look here. Let's go in here, like we had found before, in under examples, basics, and Blink. Okay. So we're gonna look at this sketch here, the empty one, and we are going to write our code. We're gonna borrow some things from Blink, just to get into a practice of cutting and pasting, basically. Or practicing, borrowing. I think a big part of using Arduino is that it is a practice of collage. It's a practice of, using and working with code that people have used and worked with and, changed and shifted to fit their own needs. There's no need to reinvent the wheel. Especially at the beginning when we're just learning what all of this language does. Okay, so if you remember in the last section, at the beginning, right above void setup, that is where we identify where things are, where Arduino knows things are plugged in. We are not using the built-in plugin, we're using one that's connected to pin number 13. So what we will write is our constant, const, integer, LED that we're going to name LED, pin with a capital P, is equal to pin number 3. And then we're going to end with a semicolon. Every sentence ends, every statement ends with a semicolon. So that's super important to note. And know that when writing code in Arduino, which uses a variation of C++, capital letters, it is cap sensitive, so capital letters will matter and lowercase letters will matter. Okay, that's all we need to write at the beginning before we even set up our code. The constant thing that will not change is our LED pin number 3. Awesome. Okay, let's get into our void setup. So we'll delete this and we're going to take a look at this. What is this? A curly opening bracket? A curly bracket? Every curly bracket, every function, the void setup function, has an opening curly bracket and a closing curly bracket. You notice when I highlight it, the other one, its pair, gets a box around it. that means that in order for this to work, you need both the opening and the closing curly bracket. Same with the first line. In order for this sentence to read, it needs a stop section, which is our semicolon. So let's make our back to our void setup, and then the parentheses, void setup, parentheses, and then opening curly bracket. Cool. So we want to set up, similar to our blink section, we want to set up our pin mode, which will be an output, but we're just not going to name it LED built-in because that's not what we're using. So we'll go ahead and type pin, capital M, mode, our bracket, LED, capital P, pin, comma, and then all cap output, bracket. Then we end it with our semicolon. Awesome. The other thing that we need to do is we got to get into a practice of writing what each of our code lines mean. If we don't, then it's going to be really confusing. If we forgot what it is that we did, we're going to go back, look at our notes, and be like, what does this even mean? Like, I forgot. And that's okay. I mean, at the beginning it's really hard. So in order to write notes for ourselves at the line of each, after the end of each line, we're going to put 2 slanted brackets, and we're going to write, or 2 dashes, or whatever these are called, slanted lines. And we're gonna write what this is. We're just setting up our LED pin at pin 3 as an output. Right. Cool. Awesome. Now we'll go to our loop. We're basically going to be using the exact same thing that we did for blink. So we are going to write it as, we're going to begin by making it digital write, which means that we're sending a digital signal to write that we want it to turn high, because we've labeled in the setup, we've labeled the pin as an output that we're going to send signals. So we're going to write this digital signal to LED pin as high. Awesome. Close our bracket. Put our dashes so we can make notes to ourselves. Turn on LED on. High is on. Cool. Then we're gonna write delay. We want a delay function for 1 second or 1,000 milliseconds. Close it out. And okay. Wait a second. Cool. Then we're gonna digital write and send LED pin a note to turn off, or it doesn't have off, it just has high or low, high being on, low being off. Cool. We'll put our note here, turn off. Oops, we don't need to be yelling. Turn off LED. Cool. And then we're going to write a delay, so we know that it is indeed functioning for 1 second. Wait a second. Awesome. And then we've got our curly bracket to close it off. Okay, before we even begin to upload and compile, we want to make sure our board is the correct one. Awesome. Arduino Uno. Our port is, that's interesting. Our port's not showing up. That's because it's not plugged in. Come back to it. Port. Oh, perfect. Popped up. Awesome. Okay, so now we're gonna verify, make sure everything looks good. What did I do? Oh, maybe it's not supposed to have an S next to it. There's no S's in 1,000. Okay, let's see. Looks good. My dog is barking, but it looks good. So let's upload it. Uploading to our board, and you can see here that it's blinking. We've got it turns on, waits a second, turns on, turns off for a second, turns on for a second, turns on for a second, turns off for a second, and that's it. Awesome. So we turned our first LED on. Good job.